Hi, this is the second part of our notes on modeling integer addition. For example 2, we have the instructions, use a pictorial model and number line to model the following expressions. Expression C we have is 7 plus negative 4. Expression D is negative 6 plus 4. Let's begin our process again with expression C, 7 plus negative 4. Before I move on to the actual modeling process, I want to discuss something about the way this expression is written. If you notice that negative 4 has parentheses around it, that is so that you don't become confused and accidentally think that we have addition going on here along with subtraction. What we have here is 7 plus, remember addition is an operation, a negative 4. We don't want you to think that this is 7 plus minus 4, which wouldn't make sense. So don't be surprised from here on out if you see negative numbers with parentheses around them. All that means is they're letting you know that that number itself is negative. So let's continue now with our modeling process. We're going to use integer circles like we did on the front part of our notes here. So I'm going to go ahead and begin with that now. My first number in this expression is positive 7. I know it's positive because there is no sign. In math, we've come to an agreement that if there is no minus, a negative sign in front of it, then it's automatically positive. So I'm going to draw 7 circles, all with positive plus signs in them to represent positive 7. Now I'm going to add or join underneath 4 negative circles. And here I drew 4 circles with little negative signs. So I have 7 positives being added to or joined with 4 negatives. But here is where it gets a little interesting. We have positives and negatives. Do you remember in science class when you have talking about the charges and you have electrons, which have a negative charge, and protons, which have a positive charge? Protons and electrons together cancel each other out in this case. Positives and negatives give us what we call zero pairs. So whenever you have a plus and a minus, they cancel out to 0. Plus and minus, 0. Plus minus, 0. Plus minus equals 0. And you can see that these 3 remaining positives have nothing else to be joined with, which helps us derive our answer. Now, big idea, new vocabulary word here. Zero pair. A zero pair has the value of 0 whenever you see a plus and a minus together. So for every time you see a plus and a minus, that means they cancel out and equal 0 or nothing. And how that relates to our problem now is we have 4 such 0 pairs above. I'm going to kind of go ahead and just mark them out and show that they're not really that important to me anymore. They all went away, disappeared, equal to 0. And all I'm left with now are these 3 lonely positives, all by themselves. And that is also the answer to this expression. 7 plus negative 4 is 3. Now let's begin to model this with a number line. I'm going to go ahead and draw a page break and then rewrite my expression, 7 plus negative 4. And since I'm dealing with number lines, I'm going to have to construct, you called it, a number line. In this case, I made mine kind of big. I took up all the space in the column that I gave myself, and I started from negative 2 to positive 9. I knew how to make my number line because I looked up here at my 2 digits. I'm looking and I see I have a lot of positives, more positives than I have negatives. So I knew I'm going to have a lot more space in the positive area that I'm going to be dealing with, which is why I have a lot more positives than negative numbers in this number line. So go ahead and construct this number line now. When you're ready, go ahead and move on to the next part. After constructing my number line, I then have to start making my line segments. My first line segment has to represent positive 7. That means I start from 0, like always, and then go 7 steps to the right to positive 7. Now, to join my next part, it's a little different, but not too much from the first 2 examples we had on the front of the page. Here I'm going to make another line that's going to be 4 units long, but this line is going to go into the negative direction. So here's what I do. I drew my number line again. I drew my first number, my positive 7, and then it ends right here at positive 7, which is where my line is, and my arrow meets it. I'm going to draw my second line above it at the exact same spot at 7. But now I'm going 4 steps in the negative direction, which means 4 steps, 1, 2, 3, 4 to the left. I draw a line to show that I stop, and the arrowhead shows the direction I came from. So one thing I notice here now is when I'm adding positives and negatives, I get a change in direction. Positive went to the right, but when I added a negative, it made my other line go to the left. But guess what? How can I figure out my answer? Well, it's exactly where my second line ends up. Let's go ahead and draw this final part. So I know I had positive 7, and then I added above that here 4 negatives, and wherever it ended up is my answer. I drew kind of a little line straight down, and I end up at positive 3. And if I look at my answer from above, I see that that matches up. I have a 3 here. I also had a positive 3 here. They both are equal, which means I know I did my work right now. They verify or check each other. Let's go ahead and move on now to example D. Example D says negative 6 plus 4. Now in this case, we're dealing with more negatives being added to a few positives. In example C, we had more positives added to a few negatives. But the process is exactly the same. To model it, we'll begin with the integer circles, the pluses and minuses. And here, I wrote 6 negative circles, so 6 circles with minus signs or negative signs in them, being joined with or added to 4 positives. Do you remember what's going to happen next? Something between these minuses and positives is going to happen in this equation. And if you recall correctly, you see we have all these, as I circled them here, canceled out and equal to 0. And whatever's remaining gives us our answer. So I went ahead and scratched out those 4 0 pairs and everything that was equal to 0. And I just went ahead and brought down what was remaining. In this case, 2 negatives. Therefore, negative 6 plus 4 equals negative 2. That wasn't so hard. Pretty easy, I would say. Let's go ahead and now do the number line, which is also very easy. Here, I made a number line that extends from negative 8 on the left all the way to positive 2 on the right. And I spaced it out as evenly as I possibly could. Now I'm going to go and begin to make my line segments. My first line segment has to reflect my first value, negative 6. And as always, we know we begin at 0. So I start from 0, and my line has to go negative 6 or 6 steps to the left of 0. I put a line where I stop and an arrow tip to show my direction. And just like in my previous example, I'm going to have to add to this another line. I'll do it on top that shows 4. Since there's no positive sign up here, I know it's a positive 4, which means I'm going to go to the right 4 steps. And that's exactly what my next picture shows here. I had my negative 6 to the left, which is right here at negative 6, and my second line lines up with it and begins to go now 4 steps in the opposite direction. Where it stops ends up being my final answer. And in this case, my final answer is negative 2, which does correspond to my answer up here when I did the integer circles or the counters. Negative 2, negative 2. So I know my answer is correct. Those are some examples of how you model with integer chips. Sometimes they're called counters, sometimes they're called a mat, and with a number line.